Hi, my name is Hyeyoung and I'm going to discuss Chapter 8 of Head-First Programming with you. It is about GUIs and data, and we will take this course slowly and step by step. The first thing we need to understand is, what are GUIs? GUI stands for Graphical User Interface, and they are used to read and handle user data. It can even be said that choosing the right widgets can change your user interface to user heaven. This means that knowing which widgets to use is essential, and we will cover that part in particular for this video. The two types of widgets that we can discuss are the ones that can accept plain text and the ones that can present a menu of options. In the book, there is an example of the HEDX Deliveries Company, which is a small delivery company looking to expand. HEDX Deliveries wants to build a whole new book delivery system that can deliver to all around the country. In order to implement such worldwide system of book deliveries, it needs to use a system that is simple to use, a system that uses graphical user interface. In the interface, the user enters the details for a new delivery. The entered details include description of the contents, address that the delivery is heading to, and the name of the HEDXD pod it will be dispatched from. When the user clicks the Save button, the details are saved into a file called deliveries.txt. When we are finished with making the GUI, it will look like the picture in the slide with the sections, dpot, description, and address, and also the Save button. In order to read the data from GUI, we need to create an interface with places to enter the text. Also, we need to access the written information. Data will need to be stored away into a file, so you need some way of asking the interface what text has been entered. When someone clicks on the Save button, you'll be able to write the data to the deliveries.txt file. Also, you will need to append this information to the file whenever someone presses Save. So, for example, someone could enter Seattle, Washington for dpot, books for description, 1 Main Street, Anytown, Washington for address. When the person clicks Save, the data will be saved into the deliveries.txt file. Before we go on any further, we need to address two important widgets for the users to enter text. The first one is Entry widget, which enables the entering of single lines of text. For example, if we want the user to write their email, which is a single line of text, we can write down the code your email equals entry app. The second important widget is Text widget. This is for longer multi-line text. Examples for using this widget can be in the cases of email messages and word processing documents, which tend to go over 1 line of text at least. For example, if you want someone to copy their whole document, we can write down the line of code your document equals text app. Now that we have learned how to write down the line of code for requesting the users to enter their text, let's find out how to read and write data to entry fields. When someone enters text into an entry widget, Python stores that text somewhere in memory as a string. If you want to read the string, you just need to call the widget's get method. For example, if we write down the code your email.get, it returns the string of the user's entered email. If we want to change the contents of the widget, we can do it in two ways. The first way would be to add text to the widget using the insert method. To use this method, you would need to say where you want the text inserted in numbers. The entry fields are indexed from 0, so if you want to insert Python in front of the first letter of your email, you can write the line of code your email.insert 0, Python. The second way is the delete method. Delete method lets you remove text from the field. Since you may want to delete the entire contents of your field, decanter gives you an end symbol that lets you delete all the text. End is a special value that represents that last character in the field. For example, if we want to delete your whole email entry, we can write down your email.delete 0, end. We have only looked at how to read and write data from entry fields which only have a single line of text. What about text fields that are larger? What happens when we want to access particular lines and columns in text fields? To answer these questions, we need to compare entry fields to text fields. While entry fields use a single number to index the contents of the fields, text fields use a string in the form of row, point, column. For example, if we want to retrieve the first character of the document entered, we would write down the line of code, your document, point get, 1.0 in the string format, comma, end. Row 1 and column 0 would refer to the first character in the field. Delete and insert method work in the same way with entry fields with the addition of row, point, column. I think this will be better shown with the examples below. If we want to delete the whole document, we can write down your document, point delete, 1.0 in string format, comma, end. Just think that 0 has changed to 1.0 in a string format. If you want to insert winter is coming in front of the first letter of the document, write down the line of code, your document, point insert 1.0 in a string format, comma, winter is coming. As in the previous case, 0 has changed to 1.0 in the string format. From what we have learned until now, let's try to write down the codes to help Hyeyoung deliveries. I would advise you to write down the codes as well into your Jupyter notebook or idle and see how the codes work. I will explain the codes line by line. So the first line of the code would be from Tkinter import star. Import star means to import everything from the Tkinter module. Also, the next step would be to define the save data function. So to define the save data function, we would need to write def save data and then indent, and everything indented from that line would be defining the save data function. So we need to now open a text file called deliveries.text and appending the text to the end of the file and also assigning it to the variable file d. So file d equals open deliveries.txt, comma a. And then we write dpot onto file d. So we write file d.write dpot and then \n. Then we use a get function to return the contents of an entry field. So we write the corresponding contents of an entry field regarding dpot. So file d.write %s \n %dpot.get. Then we need to repeat what we have done above for description. So we write file d.write description \n, and then we write again file d.write %s \n %description.get. Then we need to write address on file d, but we need to be sure that address is not an entry field but is a text field. So we need to use get 1.0 in a string format, comma, end to return the contents of a text field. So before we do that, we have to write address on file d. So we do that by saying file d.write address \n. So this is the same with the entry fields, but for the get function it differs. So in order to write the corresponding contents of a text field regarding the address, we write file d.write %s \n %address.get 1.0 in string format, comma, end. Then we cleared the fields after saving the data by using delete. So we write dpot.delete 0, n, description .delete 0, n, address.delete 1.0 in string format, comma, end. So the second part of the code is to create the GUI. So we start by saying app equals tk, and the title will be written as Hyeyoung deliveries. So we write app.title, and then we write Hyeyoung deliveries in a string. So pack function adds the widget to the window. So we add label dpot with the pack function. So we write label app, text equals dpot.pack. Since the data entry fields are in need of being tracked, we need to assign them to the variable dpot. So we write dpot equals entry app. Add dpot to the window with pack function again, so dpot.pack. And then we add label description to the window with pack function. So label app, text equals description.pack. And then we create an entry field and assign it to the variable description. So description equals entry app, and add description to the window with pack function by saying description.pack. Then we differ it up a little bit because we use a text field again. So add label address to the window with pack function which here is the same, label app, comma, text equals address point pack, but then it differs here by saying create a text field and assign it to the variable address by saying address equals text app. Then we add the address to the window with pack function by saying address point pack. Lastly, we make a save button, which is adding a save button that saves data with pack function, button app, comma, text equals save, command save data point pack. So the save data used in the command is the save data function that we defined in the previous slide. Then we make the main window of the program visible until the user closes with main loop function. We write the code app.mainloop for that. So this would be the result of the code that you have written. So if you run the code on your idle or your Jupyter notebook, this will pop up in your notebook. However, it needs to be addressed here that there is an ambiguous entry problem with the previous code because there are many things that people could write to dpot because there's no limit to what a person can choose from. So a consignment of college football jerseys was sent to Cambridge in England instead of Cambridge in Massachusetts. So this caused an ambiguous entry problem for the headX deliveries. The system is doing exactly what it was designed to do because it received the text and it saved the text into the deliveries.text file. So the problem is that the entry text fields for dpot lets the user type pretty much anything into the space. So there's no control on what gets entered into the GUI. So we need a way to prevent users from entering ambiguous data into the dpot field. And let's figure out how. The first way to solve ambiguous entry problems would be to use radio buttons. Radio buttons forces users to choose a valid dpot, and they are also used when you want to allow a small number of values for a field. So if you select one of the buttons, the other buttons are automatically deselected. So as shown in the picture next to the description, we can see that when the blue button is selected, then the buttons above and below are not selected. So we can also choose only one from a small group of options. However, a warning to be shown to the users of radio button is that all radio buttons need to share a single piece of data, which is called the model. In order to create radio buttons in Tkinter, we need to remove the dpot entry widget and replace it with 3 radio button widgets, one for each of the valid dpots. The text given to each widget will be the text that appears alongside the radio button in the interface. So in the previous code, we have written dpot equals entry app and then dpot point pack. However, we're going to erase these 2 lines and replace it with the 3 radio button lines. So radio button app, text equals Cambridge, MA, point pack, radio button app, text equals Cambridge, UK, point pack, radio button app, text equals Seattle, Washington, point pack. So these 3 lines will replace the 2 lines that have been erased to encode the radio buttons. However, it should be noted that the 3 lines that we have written in the previous slide only set the text descriptions and not the values on the radio buttons. So in order to set the values on the radio buttons, we need to write the line of code, radio button app, text equals Cambridge, MA, value equals Cambridge, MA to assign the Cambridge, MA value to the text Cambridge, MA. So we need to repeat the same line of code for Cambridge, UK and Seattle, WA. So the radio buttons that we are using are actually using the model view controller. So this is when the Tkinter library keeps track of which widgets are using which models. And whenever a model changes, the Tkinter will let the widgets know about it. So the model is the data stored, view is the fancy name for the widget, and controller is the code in Tkinter that lets all of the views know when the model has changed. Since we have separately looked at the components of creating working radio buttons in Tkinter, let's look at the full code and in its full set. So pack function, as we have previously mentioned, adds the widget to the window. So we add label dpot with pack function. So label app, text equals dpot point pack does so. So string var is the new part here. String var holds a string value and this is assigned to the variable dpot. So dpot equals string var means that the dpot variable holds a string value. So all of the radio buttons are cleared after the record is saved, so we set the string var to the special value none, which means no value. So there are no string values after it is erased. So dpot.set none, and then we add the radio buttons to the code. So text is the description that appears on the screen, and value is the one that will be used in the model, which is a shared single piece of data. So radio button app, comma, variable equals dpot, comma, text equals Cambridge, comma, ma, comma, value equals Cambridge, comma, ma, point pack, and this is repeated for Cambridge, comma, UK, and Seattle, comma, WA. However, a problem with the radio buttons is that if we have a number of options that are more than 3 or 5, then we will have a hard time writing all the radio buttons down. So we need to use an option menu when we have many choices. When there are too many depots on the GUI, we use the option menu, which is the drop-down list box, and it takes up less space than the radio buttons because it can display a large list of options in a single entry field looking format. So the options menu code looks like this: label app, comma, text equals dpot, point pack, and then dpot equals string variable, which is the same as the previous code, and dpot point set none, which is the same as the previous code. However, the thing that changes here is option menu, comma, app, comma, dpot, comma, Cambridge, comma, ma, comma, Cambridge, comma, UK, comma, Seattle, comma, WA, point pack. So we have listed all the options in a single line, and we have put it into an option menu. So the 3 lines have been decreased into 1 line. One thing that should be noted here is that the second parameter must be the model. So in this case, option app, comma, dpot here, the second parameter is the model, which is dpot. To make the code for options menu a little bit more clearer, we use dpots equals, and then we make a list for dpots. So Cambridge, comma, ma, Cambridge, comma, UK, comma, Seattle, comma, WA will be inserted into the dpots list. And then on the next line, we will write option menu, comma, app, comma, dpot, comma, star dpots, point pack. So star means take the rest of the parameters from this list and insert them here. So we take the components of dpots and we put it into the options menu. So let's utilize what we have learned until now. So let's build a food delivery GUI for Python Pizza. So the 5 things that we need to include here is first, create an entry field for your phone number, and then an option menu for the Python Pizza locations, and an option menu for Python Pizza menus, and then the 4th one would be to create a text field for additional requests, and the 5th one would be to create a text field for your address. I hope you took some time to do the exercise on your own. This is the code for creating the Python Pizza delivery GUI. The code is similar to the one we have seen previously in this video for this part, thus just remember 3 things here. Number 1, creating a save data function, which saves the data into a text file. Number 2, text fields should use row point column in a string format to find indexes. And number 3, clearing the fields after saving the data. If you have utilized the code shown previously in the video, this part of the code would have been pretty easy for you as well. Well, at least I hope so. Number uses just a simple entry field, so using entry app would have done the trick. For Python Pizza locations and menus, if you have used the code for making option menus with the list, your code would have been quite efficient as well. Additional requests and addresses require text field. Thus, if you use a text app for both cases, you would have successfully created the sections for both of them. Lastly, for the save button, which is actually the request for delivery button now, if you change save to request for delivery, it would have done the trick. So this is the Python Pizza delivery GUI that you have created with the code shown before, or the ones that you have created on your own. So phone number, it has an entry field for your phone number. Python Pizza locations has the locations in an option menu format, 성도 1동, 성도 2동, 성도 3동. And also the Python Pizza menus has an option menu for pepperoni, cheese, Hawaiian, super supreme, vegetarian, and all meat. And there are text fields for additional requests and address, and it's cut off, but there's a request for delivery button right below the address. So if you use this Python Pizza delivery GUI, then the users will have an efficient delivery service using experience. So I hope you can make your own GUI after you have watched this tutorial. And if you have any additional concerns or questions about this subject, you can look it up in Chapter 8 of Head First Programming. Thank you for listening.